Hello everyone, let's solve a very interesting problem today. In this problem we are given the start and the end of non-overlapping intervals. It is also given that these intervals are sorted in ascending order. And we are given a new interval and we have to insert this interval such that there are no overlapping intervals. And we are allowed to merge overlapping intervals. Once we are done with the insertion, we have to return the new intervals with the necessary changes. Let's look at the example given. These two are our original intervals which are non-overlapping, and when we try to insert the red interval, we see that there is an overlap with the first interval. To make them non-overlapping, we'll merge these two intervals into a longer interval and this will be our answer. Let's try to come up with an intuitive solution for this. Let's look at the scenarios in which there will be no overlap with the existing intervals. In the first scenario, our new interval is before the start of all the other intervals. So we'll just insert it at the start and after that we'll add all the other intervals. In the second scenario, we have some intervals before the start of our new interval. And we also have some intervals after the end of our new interval. In the third scenario, all the existing intervals are before the start of our new interval. Now let's see the case when there's an overlap between the new interval and one of the existing intervals. In the first scenario, we see that there's an overlap and we have to merge these two intervals to form a new interval. This new interval must include both these intervals, so it makes sense to have the start, the minimum of these two starts, and the end to be the maximum of these two ends. Similarly, for our next scenario, we have to merge these two intervals, and the start of the new interval would be the minimum of these two starts, and the end would be the maximum of these two ends. In our next scenario, the existing interval is a subset of the new interval, so we'll merge these two and our new interval will represent the merged interval. In our last example, the new interval comprises of two different existing intervals. Even in this case, the start would be the minimum of all the starts and the end would be the maximum of all the ends. Let's see this in action with the help of a complete example. Our first interval is before the start of the new interval, so there is no overlap. So we'll include this interval as it is. For our second interval, we see that there's an overlap. So we'll create a new merged interval and our new start value will be the minimum of the start values. Similarly, for our next interval, there will be an overlap and we'll minimize the start value and maximize the end value. Similarly, for our next interval, there will be an overlap and we'll create a new merged interval. And again, for our next interval, there's an overlap. The start value will remain the same because we have to minimize it. But since we are maximizing the end value, this will be the new end value. And when we go to our next interval, we see that it no longer overlaps with our new interval. So we'll add the new interval and after that we'll add all the remaining intervals. The time complexity of this would be O of n because we have to go through all the intervals once. And if we don't consider the space required to store the result, our space complexity would be constant because we only have to maintain the start and the end of the new interval. Let's implement our solution. We'll first define a result array to store our output. Now we'll go through each interval in our intervals array. We'll keep a variable to store the start and the end of our current interval. Similarly, we'll keep a variable to store the start and the end of our new interval. Now we'll handle the case when the new interval is before our current interval. In that case, the new interval's end should be less than the start of our current interval. Since there is no overlap, we'll first add the new interval and after that we'll add all the remaining intervals. So we'll just extend the output array with the remaining intervals and then return it. Now we'll handle the case when there is no overlap and the new interval is after our current interval. In this case, the new interval start value should be after our current interval's end value. In this case, we'll add first our current interval and the new interval will be used to check with the next interval. Now let's handle the case when there's an overlap between the intervals. In this case, we have to create a new merged interval with its start value being the minimum of the start value of our new interval and our current interval, and the end value being the maximum of the end value of our new interval and our current interval. Now let's consider these two scenarios. The first scenario represents a case in which there is no overlap and the new interval is after the end of our last interval. In this case, since we have not added the new interval yet, we have to add it. Let's consider the second scenario in which there is an overlap between the intervals. In this case, we have to form a merged interval comprising of all these three intervals. And since we have just created this interval and not added it yet, we'll add our new interval after going through all the intervals. And after this, we can return the result. Let's submit our solution. You can see our solution is accepted. I will also recommend to you to go through the intervals playlist to solve more such problems. If you have any doubts or concerns regarding this solution, please mention in the comments. If this video was helpful, please leave a like and subscribe to the channel for more such content. Thanks for watching.